Okay, so hello everybody. We are now in our fourth module for consumer chemistry. So just a recall, for the first module we did an intro about organic chemistry. Organic chemistry is the study of compounds, special compounds that contain carbon. And then in the second module we studied about hydrocarbons. There are three kinds of hydrocarbons. What are these? We have the alkanes, the alkenes, and the alkynes. Also, we studied about cyclic hydrocarbons. So we had the straight chained hydrocarbons. We also had the cyclic hydrocarbons. After that, we had another lesson about aromatic hydrocarbons, which are not just some cyclic hydrocarbon, but this time they have a special ring which is called they have benzene-like structures within them, so aromatic hydrocarbons. Now we are set to study on a new group of organic compounds, and this time we're going to explore about alcohols. Okay, let's go. So for this session, let's have an overview, the first one, the objectives, and then the functional groups, a little intro about what is this so-called functional groups, and then the alcohols and how to name them, what are some examples and their properties, and then some activity type. Okay, so for this session, we're going to have a few objectives. The first one, identify the general structure of an alcohol. Then use some IUPAC or IUPAC rules to name these alcohols systematically. And then we also have to identify these structural features classifying alcohols as primary and secondary or tertiary alcohols. And then for the fourth one, we will explain some properties and some important uses of alcohol. Okay, so we did this KWL chart in our class, and you mentioned that what you know about alcohol, most of them you know alcohol about from mga disinfectants. You also know about alcohol from like the liquor. So there are different types of alcohols too, and we will explore them in the next slides. So functional groups first. So before we go to alcohols, we have these functional groups. So what are these? So look at these pictures. All these substances and compounds all around us, some of them are not just simply hydrocarbons or aromatic hydrocarbons. Some of them have special repeating patterns in their chemical structures, and they have unique characteristics as well. So what objects can you recognize from these pictures? We have the wine. We have this. This is like an essence, and then this is a fragrant essence, and this one must be some spice. Then this is a banana, and this is ethyl alcohol. Some injection must be a vaccine, and this is antifreeze, and this is a mothball. Okay, we learned about some, like the mothballs, some of them, because they have been discussed in our aromatic hydrocarbons. So this time we will focus on one group, and these are the alcohols. Okay, so observe these molecular structures. So the vast majority of organic molecules contain elements in addition to carbon and hydrogen. It's not just the, by the way, the red one, this is oxygen, and the gray ones, these are carbon, and the white ones, these are hydrogens. Okay, so it's not just the repeating structures of carbon and hydrogen. We also have other elements, and some of them come in groups. So most of these substances are fundamentally hydrocarbons that have additional atoms or groups of atoms called these functional groups. Okay, that's an additional group of atoms called functional groups. So we have this a few groups which we call the functional groups. Okay, here are the different functional groups. They're similar to what we mentioned in class about the substituents. So the one that connects to some pattern of a long chain of C and H. Okay, they connect. So the same with the substituent groups, they combine. So we have some functional groups here, which then tells us the different classes or families of organic compounds. So we have this hydrocarbons or the halides, and these are the functional groups. So in their functional group, what is repeating is the presence of a, what's this? This is a halogen. Okay, we have the fluorine, chlorine, bromine, and iodine. For the alcohols, another class, alcohols, so the functional group is this OH. So we will learn later. And so on. So we have esters, ethers, aldehydes, ketones, carboxylic acids, esters, amines. So these are the corresponding functional groups with the repeating pattern of atom with repeating pattern within their whole molecule. So, and by the way, the R and the R prime symbols here, they represent hydrocarbon fragments or the chains of hydrocarbon, which may be the same or different. So here, for example, for the halo hydrocarbons or the halides, we have R-X or the general formula. So for example, you have a methyl group combined with an iodine. So must be methyl iodide. And then here. So there is a group just like this. So you can notice for ethers, there's always this pattern. And for aldehydes, there's always this. For alcohols, there's always this. So functional groups, again, so it's an atom or a group of atoms in a hydrocarbon derivative that contains elements in addition to carbon and hydrogen. Okay, so functional groups are also important. They're very important because they are the units by which we divide organic compounds into families of compounds. So we have these families: hydrocarbons, hydrocarbons or the halides, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amines, and so on. So they play an important role in the formation of the different biomolecules also. Example, in our DNA, in the proteins, in the carbohydrates, and the lipids. So here are some structural representations of these functional groups. There's so many other types, but the common ones are these. And here are the other ones. So yeah. Let's have to focus on alcohols. Okay, so you can see we have two examples here. We commonly hear these two, the methanol and the ethanol. So methanol, the common name for methanol is methyl alcohol, and for ethanol we have the common name of ethyl alcohol. So more commonly you must have heard of the ethyl alcohol right now because we use this frequently because of the ongoing the current situation wherein we need to disinfect using ethyl alcohols. So methanol is an example of an alcohol which is commonly known as a wood alcohol also. So these are some of the common examples. So you can read from the module about the properties of these two, and I assigned you the time to explore more about their properties. So for this video, let's focus on the technicalities, such as the naming. Okay, so alcohols. So let's read. The alcohols are characterized by the presence of an OH group. Okay, so before you must explore the properties, you watch that video that I gave you in our Google Classroom. Okay, let's continue. The alcohols are characterized by the presence of the OH group. The OH group is called hydroxyl. Okay, some common alcohols are listed here in this table, and the systematic name for an alcohol is obtained by replacing the final E of the parent hydrocarbon with this suffix "ol". Okay, the position of the OH group is specified by a number where necessary and chosen such that it is the smallest of the substituent numbers. Okay, the OH must have the smallest number as possible. So a summary, an alcohol, a hydrocarbon derivative in which the hydroxyl group OH is the functional group. Okay. It has a general formula also of CnH2n plus 1 OH. Okay, we can represent alcohols in different formulas. We have this version of the general formula of the functional group, actually OH, and then the C here can be connected with different alkyl groups. We have the structural formula like this. This is another example, and the line angle formula. So you specify the OH here at the end. And some books, they write the other end with a CH3, but you can also not write because it's understood that when it's a line angle formula, the ends and the vertices are always carbon, unless, just like this, we specify that it is an OH. Okay, so another is the condensed structural formula, wherein you do not use the dashes, the lines. So CH, but the sequence is written just what it is. So CH3, CH2, CH2, OH. So there is this OH. The molecular formula, this follows the general formula that we mentioned before, the CnH2n plus 1 OH. Okay, so 3, and then 3 times 2 is 6 plus 1, so 7 OH. So this is how you write the molecular formula of alcohols. Now let's go to the rules. So first, we have common name and the IUPAC or the IUPAC systematic name. For the common name, I wasn't able to write it in the PowerPoint, but for the common name, the example is, let's have like ethyl alcohol. So the common name is that you write the alkyl parent name with additional word of alcohol. So that's simple. Ethyl alcohol, methyl alcohol, isopropyl alcohol. That's the common name. So the rules for naming then in another version, which is the IUPAC system, number 1, select the longest chain of carbon atoms containing the OH group. So again, always find that longest chain that contains this special group. Number 2, number the chain such that the carbon with the OH group gets the lowest number as possible. Okay, and number 3, obtain the root name from the parent hydrocarbon chain by replacing the final E with a O. And then lastly, you name any other substituents as usual. In other words, alphabetize. Alphabetically ordered. Okay, let's proceed. So let's have these examples. How should we name these examples? So again, find your longest chain. So this is our longest chain. Well, where should we write our number 1 first? So dapat your OH must have a smallest number. So start here. 1, 2, 3, 4, 5. So this is a 5. So this must be a pentane. And then your OH group is at 2. So this is called, you remove the E. So you write the number first, 2-pentan. Just write the O. So 2-pentanol. That easy. Next, how about this? 1, 2, 3, and 1, 2, 3, 4. So we can start here. 1, 2, 3, 4, 5, 6. This is a hexane, but it has 3. So we can have 3-hexanol, like that. Okay, should we check the answers? This is a 2-pentanol and this is a 3-hexanol. Okay, correct. Next, how about this? So 1, 2, 3, 4. What's this? Butanol. Butanol. Okay, so in your butanol, this is your first. So let's just look at the structure first. So your OH is in the middle. Your CH3, this is a methyl. In another group, an ethyl. But just never mind those because we can name it directly using this butanol. So what number is the OH connected to? It's at carbon 2. So we can name this as 2-butanol. Right. Next. This is a chain, but this time we have a special guest. This is chlorine. So let's name our parent chain first. Where should we start? From here or here? So OH is found here, so let's get closer to OH. So this is our 1, and this 2 and 3. So this is propane, so we can have propanol. So propanol, we have our 3-chloro, your 3-chloro because it's connected to the third carbon. So 3-chloro dash, your OH is connected to carbon 1, so 1-propanol. Okay, that's just how you name it. Are we right? Yes, it is. Next, letter C. This time, where is the longest chain? Okay, we can either go from here to here or here. So let's just have this line, the straight line, because it's the same. So let's start at this side because OH is found here. So 1, 2, 3, 4, 5, 6. Okay, let's not write a number for B because numbering is only for the carbons. So 6, this is a hexane and hexanol. So branches first, we have 6-bromo. What else? We have 2-ol. So how should we name this? So the substituent first, let's have 6-bromo, 6-bromo 2. So always have a dash when you separate a letter and a number. So 2-hexanol. Okay, is that correct? 6-bromo. Oh, we have another. We missed this part. Okay, why? Because this one is not accounted yet, so we can erase our answers because we missed the methyl. Okay, so actually we missed this methyl up here. So not just the 6-bromo and the 2-ol, but also the methyl. So the methyl is connected at carbon 2, so 2-methyl. Okay, 2-methyl. So the name now. So let's arrange. Which should we write first? The bromo or the methyl? So B comes first. So this is 6-bromo dash 2-methyl and 2-hexanol. That easy. How about this? So here are some common examples again for alcohols, but this time it's in line angle formulas. So there's no CH3 in the examples. Let's try. Here is a carbon 1 and 2, so this is an ethanol. So let's have our 1 here because OH is at here, so it's 1-ethanol. But actually, if it's only 2 carbons, no need to write your 1 number. So just ethanol. Okay, well, the common name is, what should it be? It's ethyl alcohol. It's ethyl alcohol. Next, 1, 2, 3. So next to F is prop. So propanol. Your propanol, it's your OH is connected at the first carbon, so 1-propanol. So the common name is propyl. So the formula for common name is alkyl plus the word alcohol. Propyl I think we should switch to another color of the pen since red is a little strong. How about this? So how many carbons do we have? We can start here because on both sides it would be the same number. 1, 2, 3. So this is still a propanol, but your OH is now connected at 2. So 2-propanol. This time, OH 1, 2, 3, 4. It's at 1 dash, what's 4? Butanol. Butanol. How about this? This is also 1, 2, 3, 4. This is also a butanol, but the OH is connected at 2. How about this? So we can have, do you remember this kind of formation? This one? What do you call this group? Okay, remember this is not a benzene ring, okay, because there is no double bonds inside or no circle. So just to be safe, this is a cyclohexane. Cyclohexanol. You can have one. Automatically, if there's only one branch OH, so it's just cyclohexanol. Next, let's have this example. The numbers are given already for you. You start at this side because your OH would be the guide on where you'd start first. So the closer you are to the OH, that is where you start your numbering. So let's account for the parent chain first. How many? The carbon 1 starts here. This is your first carbon. Green. Green looks calmer. So let's have C 2, 3, 4, 5, 6. So this is a hexane. Hexane. So your hexane becomes hexanol. And then what are your branches? First, let's have the OH. So it's at 1. 1. And then your, what's this? Methyl is at 2. And this time at 4, we have a dichloro. 2 chloros. Is it right? Yeah. Dichloro. So what should we write first? Methyl versus chloro. So chloro first. So 4, 4 dichloro. Dichloro dash 2 methyl dash 1 the parent hexanol. Okay, that's how you name it. So we also can classify alcohols. We're now on another objective. According to the number of hydrocarbon fragments or alkyl groups, or the R's, bonded to the carbon where the OH group is attached. So your OH group is attached to only one carbon, and if this carbon is attached to only one, that is what you call a primary alcohol. Okay? Or one R group only. So your R prime, and your R double prime, which may be the same or different. Chains of hydrocarbons or cyclic hydrocarbons, or yes, any alkyl group would represent all these. Okay, so if there's just one that connects to this main carbon, that is what you call a primary alcohol or a 1-degree alcohol. Next, if this C that holds your OH is attached to other 2 alkyl groups, this is a secondary alcohol. So it's 2-degree alcohol. If your C, where your OH is attached, is connected to three other groups, so this is a tertiary alcohol or a 3-degree alcohol. Let's try to classify these. So let's have, where is the main carbon? So first you locate your OH. Let's try to use the red this time. Okay, your OH is here. So your OH is connected to this C. So your C is connected to one other group and one other group, because this is also a carbon here at this point. So how many? You're connected. This main C is connected to two others, so this is a secondary alcohol. How about this one? So your OH is connected to this C, and this C is connected to 1, 2, and 3, so tertiary. Okay, and your OH is connected to this carbon. This carbon is connected to only one C here, so it's a primary alcohol. So you just count on how many other groups are connected to the main carbon that holds your OH. Easy. Let's check our answers. Okay, got it right. So we also have types of alcohols wherein there would be many hydroxyl groups that would be connecting. So that is what you call a polyols. But the common ones, we have the diol and the triol. So let's read. In the IUPAC system, a compound containing two hydroxyl group is called a diol. That's not diol, okay? So it's diol. So one containing three hydroxyl group this time could be called a triol, and so on. So just like the dimethyl, trimethyl, we just use the prefix di, tri, and so on connected to this main suffix ol. Okay, in the IUPAC system also, names for diols, triols, and so on, the final E in the name of the parent alkane is retained, so this time retained, but you use the diol, triol. So for example, 1,2 ethane, so it's ethane diol. Look at the pattern, so we don't remove the E. Okay, as with many other organic compounds, common names for certain diols and triols have also persisted. So there are common names that are given even before the system of naming was established. So we also have to take note of some common names, some Ramanpur. Okay, compounds containing hydroxyl groups on adjacent carbons, okay, are often referred to as glycols. So kung inyong OH kay nagsunod-sunod sila, like the carbons that they are connected to are next to each other, they are the types that we call glycols. Ethylene glycol and propylene glycol are from ethylene and propylene, that's why it's called ethylene. So these are some common names lang sa propylene glycol, ethylene glycol. So a summary, if it contains two hydroxyl group, it's a diol, 3 hydroxyl group, triol. Okay, let's have these examples. So as you can see above, it's a ball and stick model. So the red again is an oxygen. You must get used to some chemical colors, okay, elemental colors. You have the red, the black, or the gray. This is carbon. Okay, if your book follows the standards, these are the usual colors. Okay, so you're not really the standard, but this is what chemists use. The white ones, these are the hydrogens. Okay, so we have these kinds of we actually have unboxed these kinds of structures in the laboratory from last week. So natay inani nga mga ball and stick models. So when you go to school soon, you can play with this and make your own molecules. So look at the first structure, two carbons. So this is the simple form. So it's written in a structural formula. So CH2, CH2. So naalang sa ubos yung OH, but here it's alternate. Okay. So you have two OH. This is a diol. Okay. So how do we call this? How many carbons? 1 and 2. So it's, let's write numbers 1 and 2 here. So 1, 2, dash 1 and 2 carbons, it's an ethane. So ethane. ethanidiol or ethane diol. The common name for this one is ethylene glycol. When your OH is at adjacent carbons connected, glycol siya. Next, this is a diol too. Yes, it's a diol. This is a glycol too. Kung sunod sila, yes, it's a glycol too. Where should we start our numbering? Should we start here? No. So, smallest number as possible gihapon ang imong oxygen, ang imong mga OH. So, 1, 2, and 3. So, this is how it looks like. How do we name? So, it's 1 and 2. 1, 2, 3. So, parent name is propyl. So, propane for propane diol. Okay, propane diol or common name of propylene glycol. Next, this is a triol now. Kay tulo ka OH. This is a glycol. Yes, kay sunod gihapon. So, how should we write the numbers? So, you can start on any side. Kay equal naman. Puros na yung OH. So, 1, 2, 3. What's this? Still a propane. So, propane. But this time it's a triol. Propane triol. Let's check. Okay, so this is the common. These are the answers actually. So we got it right. 1, 2, 3 propane triol. The common name is glycerol or glycerine. Some common structures or molecules in the mga fats ni sila. Okay, so we're actually done with how to name alcohols. I think it's easy for you because you're now used to naming hydrocarbons. So just a review. Okay, the longest chain of carbons containing the OH group must be found. You must find the longest chain that holds the OH group and number the chain such that the carbon with the OH group gets the lowest number as possible. Okay, obtain the root name from the parent hydrocarbon of this chain and replace the final E with the ol. And name other substituents as usual. So order them alphabetically. And also for polyols, you retain the parent name with an E, but add it with this diol or triol and also the numbers. Include the numbers where they are connected. Okay, let's go to some physical properties of alcohol. So the alcohol can have physical properties and chemical properties. Physical properties first. Solubility in water. So solubility in water means when you add that substance in water, the water is able to break those bonds. So meaning ang kato siya nga substance kay mo katag siya within the water. So ma-dissolve siya. So both liquids man ni siya, possible na siya. But here is a pattern. Let's read. As the number of carbon increases, it requires more energy to overcome the hydrogen bonds present between the alcohol molecules. So, when generally kung mo-dissolve ang substance, the solvent, ang tig-dissolve, iya gani i-wrap ang mga molecules ato and try niya to break down. So, alcohols have this OH structure. Okay, here. Alcohol na siya OH, this part. The water also has OH. So you remember, we have two lone pairs, and this is more technical, but you don't really have to. So, dere OH na atay mga electrons dere nga extra. You still remember about the lone pairs? So, these two, this is attracted to the water molecule, and it forms a hydrogen bond. So, iyang i-connect siya dito. I-break niya ang bonds. So, mahimo na siya mga simple forms. And mabuak siya from this main hydrocarbon chain. So, to overcome the hydrogen bonds present between the alcohol molecules, here, so within here, naman po siya hydrogen bonds. Need siya more energy. So, if magkataas imong mga alcohol compound, maglisod ang water og overcome ana nga para more energy to break this down. Mao na nga magka-lisod po siya i-dissolve. Here, let's try to read. So, to overcome the hydrogen bonds present between the alcohol and molecules, in addition, larger alcohols have larger nonpolar hydrophobic regions that hydrophobic effect begins to overcome the hydrophilic effect and water solubility is lost. When we say hydrophobic, mahadlok sa tubig, magpalayo siya sa tubig. Hydrophilic, philos means love. So, moduol siya sa water. So, kani jud siya generally ang OH, mo-attract siya sa water tungod sa aning positive diri og negative. So, hydrophilic jud siya. But as your chain goes longer, magkadako yang pagka hydrophobic property. So, meaning magalisod na ang water og engulf na niya og connect aning hydrogen bond. So, as we look at this pattern sa COH, mga simple alcohol, CH3OH, methanol, infinitely soluble, ethanol, infinitely soluble, propanol, infinitely soluble. Pag-abutin, 9 grams per 100 gram of water na lang ang ma-dissolve. And here, nagkagamay, hantod, nagkataas imong chain. How many carbons do we have here? CH3, CH2, kani kay times 9 pa dyan, this is a decanol. Nahimo na siyang insoluble in water. So, relatively, di na dyan siya ma-dissolve. So, mapurma ana niya, either one substance mo stay sa ibabaw, mo stay sa ubos. Di pa sila mag-mix. Mauna nga, so this is the general pattern. Your chain increases, your solubility would be harder. Okay. We also have these examples here. I just want you to look at these two. Hexanol versus 1,6-hexanidiol. So, diol versus only one ol. Look at. So, magkadaghan pod, just a little addition na lang. Ang magkadaghan pod imong OH, magkasayon pod siya i-dissolve. Daghan na siyang na-dissolve of 500 grams per liter versus 0.4 grams per liter. Because ang OH nimo, it loves the water. Just try to remember that. Okay. Pero I will not give you an example of mga diol. Alin na sa mga simple. So, your rule before, this one, it works with, the pattern works generally well with mga ol. Only one nga OH. Di lang kumapil sa mga diol para di ta malibog. Okay. Next physical property of alcohol, we have the boiling point. Unsa man ang boiling point? That is when it starts to evaporate also. Kung sa tubig pa, mabukal ang tubig at a steady temperature. So, alcohols have the higher boiling points relatively to other hydrocarbons. So, your liquid, mahimo siyang, kung maboil man ta, di ba, liquid kay mo form into gas. For example, this is the surface of your liquid. Liquid ni siya diri. Ini ka boil kay gusto sila change into another phase, may mo silang gas form. So, when that happens, the bonds in the liquid, because as you remember in your grade 8, your solid is compact, a little compact sa liquid, sa gas, kay not so compact ang mga molecules. So, from some compact here, dugol ang mga molecules, gusto sila nga lagyo ang molecules na kumagas. So, that means you have to break bonds for it to boil. Alcohols have higher boiling points relative to other hydrocarbons. Why? Because, again, we have this special OH nga atong buko ng bond. Okay. The presence of intermolecular, within the molecule, hydrogen bonding between the hydroxyl group of the alcohol molecule makes it a little harder to boil. So, the boiling point of alcohol increases as the number of carbon atoms in the carbon chain increases. So, just like before, magkadaghan ang chain nimo, daghan na kang buako na bonds. So, para mabukal siya, mahimo pa dyan siyang vapor form. So, you need more energy, need more temperature para mabukal siya. So, maka-higher yahang boiling point. Boiling point, ang temperature kung kanos siya mo boil. Okay? Here, we have some examples. Look at this. So, nagka-increase siya from your water. Water boils at 100 degrees Celsius. Alcohol, ang imong methanol. Take note, ang methanol di ay, methanol was the first one. Methanol. So, ang 1 na to kay methanol. 2 is ethanol and 3 is 1 propanol. Kani siyang ethanol ug methanol nimo kay it boils before pa jud ay sa boiling point sa water. So dali siya pabukalon. Pag abot diri sa magkadaghan imong chain, here yung temperatures need ka og more. So maabot siya og mga 259 degrees Celsius to boil a dodecanon. So magkasaka. Okay. Other properties, we have viscosity. Viscosity murag the resistance of the substance to flow. Kakuan mong leak kanang ketchup, di ba? Ang ketchup very viscous yung ketchup kay ganahan jud siya itaktak jud nimo ang sudlanan. Dili siya parehag tubig nga igyabon nimo sa tubig mo, yabon na ang tubig. No? Ang kung viscous ang imong substance may compact kay ang pagkakuyog sa uban nga mga molecules so para sa ketchup imo pa siyang tuktokon para munaog siya sa sudlanan. So viscosity for the alcohol, it tends to increase as the size of the molecule increase pod because of the intermolecular forces present in the alcohol. So within the molecule magunit-gunitanay pod sila. So, ang imong ethanol, na kayo sa kabasong ethanol, na kayo sa formula of ethanol, 12OH. So, ang imong another 12OH din daghan man ang ethanol molecules within your usa ka sudlanan. So, magunitanay na sila. So, if there are longer chains not just ethanol but mga dodecanol and so on, magka-increase pa lang viscosity. So dili kay sila mo flow. So more firmly held in space. Next, flameability. Your experience of alcohol, mo kuan jud ng alcohol mo sa Bisaya pa mo sila og mo combust. The ones that we use in the lab kanang denatured alcohol or kining flying tiger, some of them are when we say denatured di ay kanang alcohol gihapon siya but giusab iyahang gipun-an ba siya karon mas mubaho or mas lahi ba siya color para dili siya i-consume sa mga tao kay para mailhan ba nga kani siya dili ni siya pwede imnon naiuban nga alcohol nga ipabaho jud gihapon-an nila mga substance nga mas strong yang smell nga para di na to kaunon kay makadaot sa lawas na meaning sa denatured. So flammability kanang gamiton nato sa not the Bunsen burner but the alcohol lamp. Ang ibutang nato sa alcohol lamp kanang ethanol na siya nga gidenature. So kana sa flying tiger. So combustion, as the size of and the mass of the molecule increase, there are more bonds to break to burn an alcohol. So mo gihapon, it really has something to do with breaking bonds. Okay? The more bonds you break, the more energy you need. So higher imong temperature para mo combust siya or mo burn. Okay, this means that more energy is required to break the bonds. Thus, the flammability of alcohols decreases as the size of the mass of the molecules increases. So ethanol, simple alcohol, wala man methanol pod, the simple one, dali ra sila ipa-combust. Okay, small size niya, the mass of the molecules kay gagmay ra pod. So mas less na siya nga ma-combust or masunog kung magkadaghan ang magkadako ang size and mass of the molecule. Ang flammability niya, the ability na ma-combust will decrease as the size and the mass of the molecules increase kay dugay na siya sunugon kay daghan na siyang bonds i-break. So need a higher temperature. We're done with the physical properties. Let's now go to the chemical properties. Combustion process, producing carbon dioxide and water. So as your chemical properties is the combustibility of alcohol. It always produces these two products. We have carbon dioxide and water. Ano lang ta? Simple. Okay, let's try. These are some of the activities found in your module, so we can answer these together. We're done with the properties. Let's now go back to naming. Naming alcohols. How do we write? So start here again because it's closer to the OH. So 1, 2, 3, 4, 5, 6. So this is a hexane. Hex 2. Okay, this next. How should we name this first? Let's find the longest chain that holds our OH. So it's this carbon and this. This carbon has a substituent, which is this one and this one. This is a cyclobutyl. Your cyclobutyl is connected with a methyl. So simply, pwede ka mag-name og methyl cyclobutyl. So special name ni siyang methyl cyclobutyl connected to only one. So only at one, na siya sa carbon 1. 1 methyl cyclobutyl, methanol. Or you can have it one word. So we will also have some examples in class. Maybe I will show this part of the video in class. And then also this one, we can answer this one in class next meeting. So try to answer first. Okay, and we will also try to open a new lesson next meeting. We're almost done with all our lessons for this year. So hopefully we can have some rest time real soon. So thank you all for reaching at this part of the video. Let's keep learning. Bye.